For number 2, nobody's wrong. Your friend's not wrong, you're not wrong. Whenever you do, or whenever you have different samples, the data is going to be different. So in this case, when you compute R, the sample correlation coefficient, you and your friend are each going to get something different. And if you went out and sampled another group of people, you'd get a different value for R, most likely. So it's common, it's expected that different samples will have different values. So nobody's wrong in number 2. So for number 6, you should type in all your data values in Excel, make a column for X and a column for Y. And then you can select them and insert a scatter. Just put a scatter plot in. And you'll have part A done here. And then if you click on a data point, any point in there, you can right click and add the trend line. And it produces that least square line, which is the line closer than any other line is to the data points. So any other line you drew would be a worse fit. This is the best possible fit of a line for these data points. And then you want this information to show the equation of the line and the coefficient of determination R squared. And when you bring up the options to format that trend line, there should be your options to display the equation and display the R squared value. And I already had those displayed and moved them up to the top there. Alright, so before we answer B, C, and D, let's just look at the chart. It seems that the more times someone switches a job or has a job change, it looks like there's an increase here in the salary. So a positive correlation that as you switch your job more often, there's more job changes, your salary's going up. That seems to be the trend. Alright, so B wants us to list the mean of X and the mean of Y, so I just used the average function built into Excel and average the X and Y column. The equation, the Excel gave that to us, so the equation of our line. Here's the equation of the least square line, and we've already plotted it, so that's done. For part C, the sample correlation coefficient is R. Now, the Excel told us R squared, so just take the square root of that number, which is what I've typed in here, square root of 0.5789, and you get R. And then the coefficient of determination, we already had that pop up. And for the last part of C, 57.89% of variation in Y is explained by this least squares line. And we get that number straight from the coefficient of determination. That's what it's telling us, that 57.89% of the variation is explained by this model. What does that mean? There's a lot of statistic words there. The Y, remember Y is our salaries, the salaries of people that we've gathered data about. So we're saying that people's salaries change, they're going to adjust over time. 57.89% of the change in someone's salary is based upon how many jobs they've had, how many times they've switched jobs. There is a remaining percentage there. What would that be? 100 minus 57.89. So 42%, 42.11% of someone's job or someone's salary changing isn't based on the number of times they switch jobs. It's based on something else. Maybe their personality or their education level or just a lucky break they got. But from our data, we can determine, we're hypothesizing that 57.89% of the change in someone's salary is based upon how many times they switch jobs. And D is just asking us to make a prediction here. If someone has 2 job changes, which means put a 2 in to the equation, determine what their salary would be. Make a guess about what their salary is going to be. So that's why we made this line, is so that we can make predictions. So we can go here now. If we put a 2 in, the line says and here I've typed in the equation of the line. The line says we would expect that person to make $32,000. Remember, our salaries here are in thousands. That may not be 100% accurate. There could be someone with 2 job changes that makes more than that makes less than that, but that's our best prediction off of the data we've gathered, is that someone with 2 job changes, this is our best estimation of how much money they'll make. And you can plug any number in there and make a guess on how much money someone would make based on the number of job changes. Now, when you're using that, make sure you keep in mind what you read on page 155 about interpolation and extrapolation. Basically, extrapolation, if you're making a prediction outside of the data values you gathered, it's not going to be as good. It can lead to unrealistic forecast. But if you use numbers in between, interpolation, in between your gathered data values, it's going to be more reliable. So you could use this equation. It'd be most reliable if you're using numbers in between 1 and 10. But if you plug in some number outside of that range, so somebody with 30 job changes, you wouldn't have much faith in your equation for the projected salary it would spit back out for someone with 30 job changes, just because that's outside of your data range.